Well, thank you for the introduction. As I was saying this morning at the technical workshop I have been very lucky to have attended the 6 CyberCamps that there have been, and for me, I am very proud of being here in Valencia, the 6th edition. This morning, as I was saying, I gave a technical workshop, and now I'm going to talk about something new, about things that I have been working on. And I think this also is important about ATT and CK and its matrix. So I'm going to explain what this matrix is, ATT and CK, the MITRE, when it arises, and what it gives us for all these red team and blue teams, and what can add for people who want to start doing red team or pen testing and auditing, which is not really red team that much, but can be used in that context. I think this is very interesting because it is foundations of knowledge, and when you get to know this matrix, if you don't know it yet, you will see that this is indeed a foundation that if we start studying it, we will find out numerous techniques that will give us quite an advanced level concerning threats. So the presentation has been done by Sarah. She was very good, so I'm not going to go into more detail about that. I am very proud of being here, and this is what we're going to be talking about today. First of all, we're going to give some context. We're going to talk about red team exercises. We're going to see what this ATT and CK matrix is. Then we're going to see when it arises, why is it so important, why it has so much value when it comes to exemplifying how a threat can affect, for example, an organization. And also, once we are compromised, what can happen to us and how we can detect and or assess if our prevention and defense systems are working properly or whether they have some voids. We're also going to look into the emulation or adversary emulation plan. And here there's something very clear. We need a plan. We need to prepare certain stages as if we were being threatened in the organization. That's what this is about. We're also going to look into different tools. There are several which are very important. For example, Caldera, which is also from MITRE. And they give us the opportunity to emulate, to have a control emulation within the organization. So we'll see a few examples of that. And what we're going to do is going from this matrix to building our own tool. So the objective is to have a concept test and create a basic tool, so something a bit more practical based on power set and all the power that gives us, so we can execute those techniques, and those techniques that we're going to use to emulate that threat are going to then help us build a tool. I'm going to show you how you can build your own tool, what elements, what stages you have to follow, what you have to take into account. Now, my philosophy is that within an organization, when you want to do adversary emulation, we can use existing tools, which work very well, but we also have a base of knowledge which has been generated within the organization that we can share collaboratively with others and then implement it on our own tools for our own processes as well. So the idea is, as I was saying, to create a basic collaborative tools. It's not liberated yet. It will be in the future. And once this collaborative tool has been created, everyone will be able to add up to that knowledge base. And we will always be checking those functions against the matrix, which is the origin. And then we'll see which conclusions we draw from this talk. So we're going to start with red team exercises. We're going to give some context. First of all, we always start thinking that every red team is going to be different. We will always have objectives and assets, which are the objectives of or the targets of the exercise. And as you probably know, red team exercises are, at the end of the day, a simulation of a potential real threat. So it works on stages, and at every stage we're going to apply different techniques to simulate that real threat. We have different vectors, which is the digital vector. This is where pen testing and ethical hacking would stay. They would not get to form a simulation. But in Red Team, we also use other vectors. We also use the physical vector. For example, when a team try to clone cards or avoid cameras or actually physically find some information or manipulate machines. And then we have a third vector, which is a social or human vector. So those are the vectors that make up a red team context. And we have to take into account that this is a simulation. The theoretical part could last months, and in real life it could last months as well, but obviously that would depend. It would depend on the actual situation. So we're saying we can extract some patterns, some different guidelines. So what are these? Defining and planning the tests, number one. So as I was saying before, planning is essential. And number two, recognizing or external recognizing and the access vector. And here we will see how we can access. And number three, initial or original compromise. This is a key point because ATT and CK, the matrix will start there. Then we have a pre-ATT and CK, which works with the previous stages. Then number four, we have internal access to the organization. And number five, we have an elevation of privileges, which is once we're in. And then we will try to implant persistence, number 6, and number 7, internal exploring, and number 8, lateral horizontal movement. And then finally, number 9, we will run tests, and then finally we will do a training. And this is to see how our defenses, our preventive measures have worked. So red team exercises are continuous process. You can have specific execution, but if this is a continuous process, we know that execution has to be continuous as well. But this will depend as well, because an organization may decide that this is a one-off. But in any case, Red Team has to help us in decision making, because in order to make decisions, I need to run real tests that simulate real threats. Now, when we talk about real threats, what we mean is that we're going to use the same techniques that the threats that have been used in the last few years have used, and the things that have affected society and the community. So what is our aim? First of all, to show what level of exposure and risk the organization has. Then we have to show the impact in the business. Then we have to show our prevention and detection capacities, as well as our response ability. So we are going to look both into configured solutions and people, which is the blue team. And of course, the blue team shouldn't know that this exercise is being run in the organization. And this is something that is a bit old, but which is as relevant today as it was before. So we're talking about here defender's dilemma. The intruder only needs to exploit one of the victims in order to compromise the company. And then we have the intruder's dilemma as well. The defender only needs to detect one of the indicators of the intruder's presence to initiate incident response within the company. And they're both true, and these are different points of view. One is the red team, the other one is the blue team. Now, behind this context, for those who don't know, we're going to go to the matrix. Now, this matrix was created in 2013, so it's not new. And as I was saying, this is knowledge base, which gives us tactics and techniques, which have been in use in the last few years in real threats. That means APT, that means many kinds of threats which have their own names and which we already know. So what MITRE did here was when observing the techniques that are being used, they could classify the different tactics and then see how those tactics are implemented depending on the techniques. So this matrix really is like a big book where you find the tactics, which are the core components of the matrix, and then in order to implement those tactics, we will have certain techniques. So the matrix is alive, it keeps being updated. So those techniques are going to be updated constantly today and in the future, because there are many new tactics and techniques that can be added. So this, in a way, as I was saying, is some sort of big book where we can find out what threats do or have been doing in the real world to impact businesses, societies, etc. So once that is clear, we will also understand that tactics are used to see the steps of high-level attacks, and the techniques are going to implement those tactics. So this is all in pre-ATT and CK, and this is going to tell us from where I have been compromised and what I can do with the threat. Right, you can see a link here which will take you to this page. This can be called the matrix browser. It has many different names. But at the end of the day, this is the matrix. But behind this, there's a lot of knowledge, which is why I was saying earlier, if you take the matrix and you start studying all the techniques, well, you will have a lot of knowledge there. Because when you study the techniques, you're not only studying the offensive, you're also mapping how it can be mitigated. You will also see the history of where it has been used and which threats have used this. So here on the first line, you have the different tactics. You can see persistence, privilege escalation, defense evasion, discovery, lateral movement. And as you go down, you have the different techniques. Now, the MITRE techniques, which can be implemented into tactics. I'm just saying this because if you have a look at the matrix, I don't think it's the case here because we only have one technique for every tactic, but you can find techniques that apply to different tactics. Now here on the right-hand side, we have an identifier, and this identifier is for the technique. Now here on the tactics, we see on which component they're acting, and then which platforms it may affect. Then you see the mitigations at the bottom, how we can protect ourselves from this. So this is very important, both from a defensive and from an offensive point of view, because from the offensive point of view, it's telling us how to do it, and from the defensive point of view, it's telling us how to mitigate it. So here, these are linked. So when we emulate adversaries with this kind of matrix, we see something very interesting, which is I have launched this technique against the organization. has it worked? I have the mitigations, I have the controls, I have everything that should mitigate that. So if it has worked, then these either are not working or have not been configured properly or are not implemented. So when you emulate adversaries, in a way what you're doing is assess on the first of all, whether the offensive will work, and also, secondly, whether your defenses are working properly. Now, another thing which is interesting is the examples that you can see here, because that gives us the names of the real threats that have used this in the past. And this is very interesting because at the end of the day, these are not techniques that no one uses. No, these are techniques that have been used by real threats, which have also affected millions and millions of machines in the world.
So let's move on to the emulation plan then. So as I said, we need to plan it, and we usually do this through a number of phases, and this is how emulation plans work, such as Caldera. We have phase 1, phase 2, and phase 3. This is an example of a real case, and they implement the step-by-step of how that threat will be emulated. And it's a threat that actually uses those techniques, because what it tries to do is to link or map the techniques to the actual threat. The actual threat used these techniques in order to compromise or get into an organization. We must remember that. So if we understand that, our plan is simple, because on the whole, we are going to be given a list of threats with the steps that they need to take. Obviously, it's not the real threat, it's a simulation, but it takes the characteristics or the main characteristics of that threat. So the recommendation is that when you emulate in this way, it should be done in an environment, a more or less controlled environment, from the point of view of having machines, a domain, and have that control to see how our system would actually react. This can be done in very little time, or if we're using many different entities, then it can take a bit of time, but generally it will be quite short. So what are we going to ask ourselves? How much time and effort will I take during the compromise? This is part of the planning process. How much time and how much resources will I need? Which are the actors that are important to the organization? The adversary techniques. Which of the techniques are covered by the organization and by the safety controls? We are going to think, what is going to protect us from certain emulation techniques? So if we've covered our expectations, then we'll see that afterwards. And then afterwards we can look at the cases of use, and this is another of the questions that we'll ask ourselves. So let's take a look at an example using Caldera. It's a tool. There are several tools available. I'll be looking at Caldera a little bit more today because it belongs to MITRE, and I think it can give you a quick idea of emulation of adversaries. It allows you to automate the process. Red Atomic and Infection Monkey are also alternative options. Caldera is like a new central on a web application where we can manage everything from there. And we get the PowerShell or BAS agents, we can generate them for Apple. And then we will put them into the systems. It will execute and they will send us a report depending on the plan that we have set up. So we have a server from which we manage everything, we manage the agents, and we send it out into those machines to see if the plan for the adversaries is correct and what happens in the organization. So we have to have a controlled area of around 20. It's important to have it under control, and we'll have a look at an image here about related to Caldera. This is where we're going to generate those agents. And people ask, doesn't it actually detect the defender directly or any kind of antivirus? Isn't that detected automatically by them? But actually what the code does is to connect against the server, downloads the functions, executes them, and when we're going to reconstruct with using our own tool, that's part of the game that we're playing. So this is actually a loader at the end of the day. It goes to the server and it executes a number of different actions that it has to do, what kind of action has to be done and how it needs to be reported. This could be detected. Yes, it could. If it was detected, all the better. But it's not usually the case. And if it's activated by you, even less so, because it's an internal action using a tool. So we can generate this screen. So we have the agents in Windows, Linux, or Mac systems. So from the planning page, you can see that you have a combo, and you can select the kind of threat. You add in a number of faces and boxes to tell you the function for which platform it is working for Azure, for Linux, for Windows, and so on. And you can see that the tactic is here. It is there with a pipe and a technique ID and a name. So this is doing a mapping with this information on the matrix. It's identifying that the technique is this and the plan will be this. In phase 2, there are several different actions. This is what you need when you're following that simulation. So don't think that these threats are going to have a huge flow. They generally won't have a great flow of actions. As you can see here, we've got phase 1, there's one technique. In phase 2, there are 3. In phase 3, you can't see it on here, but there was also 1. So there's not a huge flow, it's just a representation, an emulation. You have to remember that. So look at the representation of the results. So the presentation of results is like a timeline. We've executed this, and it's given us a green. What's that? What's the green? It's good, isn't it? Yeah? So green is good. Okay, so emulating here, okay? So you're doing the test with the first technique and you get a green result. You get the date and the timeline. Okay, then it's in red underneath. And that means there was a control that was either partially or totally stopping something from executing. So using these controls, we can see if something has stopped or a part has been stopped. We've seen this bit, but before we move on, I'm going to show you something. Here, you should see it in a moment. So we've launched Caldera. It's in GitHub. It's by Meta, and you can download it. It's there in Python. Anybody got the password?
¿Cómo? Hombre, contraseña en 5 caracteres no creo. Será admin.
So I don't think it'd be 5 characters, that would be admin.
El tema admin es la bueno, es la que viene por defecto.
It's the defect one. It depends on the version of Caldera. So when you download it, first of all, you have to remember that it's an enclosed environment that simulates a domain and simulating a machine, a computer, and it's similar to our organization. So we can generate from here the agents, and this is very simple. So this is the charger. It does nothing more than that. It's very small. You can't really see it very well. Maybe better now. So in the end, it's going to connect to this server. It'll download the agent and execute. So that's the plan. We can do the same thing with Linux. And also in Mac, the same thing. Furthermore, if you looked at the pictures, when we added some techniques following the threat, we realized that at the end of the day, the tech can be used on different platforms, because the threat is not only present in Windows, it affects all different kinds of systems. Let's go to the part of the chain, and in the agents section, we can see that when an agent is executed against a machine, Windows or Mac, then it has a home. I don't know if you've tried similar tools. When there's an execution in Empire, it's very similar to this. So the orders are predetermined, designed based on a plan, and the execution is pre-designed. So in Empire, you can interact, and you can manage the times and what goes on at every single moment. But here we're simulating real threats. So the agents would connect here. We're not going to do it because we're going to use our own tool to do that. The agents connect, they get information from the system, and they look at the status of things that they need to do based on phases. We have the adversary section here, and we can select. And based on what we select, we can upload phases with the techniques, and we can launch that plan and assign an agent. But however, here we don't have an agent, we can't do it, but we can assign an agent, and that agent will download the techniques and execute them. The results will be returned back to us. Obviously, we have the report section here about the plan, how it went. So this is the screenshot that we had before. It was red when it was bad and green when it was good, and the information that we were getting from that. So let's continue now. So, as I was saying before, we're going to a little bit of a test using a tool. It's a test with a concept, just to see that in PowerShell we can increase that knowledge based on experience and then collaborate and manage it. So let me explain a little bit about the tool, and we'll go step by step and do a demo of the tool. And this will help you to understand the entire process and also use your own collaborative tool, organizational tool, and so on. So we need a basic tool and apply these ATT and CK techniques to our organization. But based on PowerShell, we know that PowerShell is what we will use on many occasions in order to use these techniques. We're going to give an interaction there, and we'll see how agents interact in order to put the techniques into action. And we'll have a look at the mapping using the matrix. So what we say is that this is always based on experience, and that's important. One thing is what MITRE says to us, and then we also have our experience, because it's a very dynamic world, and you can feed that into your model. And that enriches what is a standard model, so the people doing the day-to-day can really add something to that. So this is why I always say it's collaborative. So what are the parts of our tool? First of all, we have the agent, as in Caldera. So this emulates the adversary. It's a code in PowerShell that connects to the server, and it downloads a function. And the function takes control of all the management and execution and the report. And then we have a central node. I would have liked to have a console with some commands and say, well, that's that. But it's important to simulate in a simple way. So as a result, I've used Flash and Python, and that's how we made the server in this particular case. So the idea is to use those agents, tell them what the plan is, tell them what the emulated threat is, and that they should give us a report with the results. So we have a flow, or a flow chart here, so that you understand it. First of all, we have the agent. We give the agent the PowerShell code, and this creates a high. It creates an ID in order to identify the agent that is connecting. And if I do this over 5 machines, obviously every machine is different, so it needs its own ID. Then I have also, when the agent is executed for the first time, it will give me information in the report, the machine number, the IP, data, and all of this helps me to identify it. So we store the information in the database, and we give it an OK. So this is the connection flow chart. Okay, you'll see it simply here. Obviously, I haven't used Flash to make this look prettier, but that's not my speciality. So planning and rollout, once I've got the plan, the agent will say, now that I've got the connection, I'm going to ask you if there's a plan for me. A plan is something that's saying you've got to execute this technique, this technique, this technique, all those phases we were talking about. Is there a plan for me? And it's a question. So, is there a plan? There's the database. If there's no plan, you say, no, there's no plan. The agent goes to sleep and then asks a few seconds later, is there a plan for me? If there's no plan, it goes back to sleep. Until eventually you answer, yes, there is a plan for you. So it creates a JSON with an agent ID and a list of tasks and a number of tasks. So the agent says, yes, now I know what I have to execute with the yes plan. So it says, give me task 1. At the end of the day, this is what Empire does and Shell does. It says, give me task 1. Here you have task 1, the function. The function goes into the memory, it executes, and that is the technique. That is technique number 1, executed. Obviously, the antivirus can go off, any protection system can go off, and it might say that that system hasn't been executed correctly. So it's executed, and the result of the execution is sent through. So we have a put result method that gives you the result. We store the result, and it goes on and on for however many tasks we have introduced. And that's the flow for the agent. What will happen in the future? Well, we'd like to be able to link all of this. So linking, what does that involve? It means executing a task with a scale of privileges, and the agent continues to execute because this is a better simulation of an actual real threat. So this is a basic tool, but it doesn't have that. So we'll just continue testing. But it's not all linked together. We test in an isolated manner. We'll do that in the future, though.
Right, so the agents are written on PowerShell. This is just summary. We generate the ID, we get the in-system information, then we send the request, then we check whether there's a plan, and if there's a plan, then we emulate the techniques, and then we have a report of the results. And this is a bit of code that you can see on the slide. This is a template from the console. So when the hi is done, one of the things that is returning is a function that is executed in memory of the agent and manages the whole plan and gets the tasks executed and then the report done. So it's just barely 70 lines. It's quite simple, and everything goes to the memory. So the more we have on memory, the better. And then talking about the node, we've got different functions. Start phase, where agents that have connected to us sort of present themselves to ask for plans. Then we have number 2, plan, to generate the plan from the interface. And then we have number 3, results, where we analyze in a very executive manner. Is it okay or not? That's it. You want to see the log? Fine. We've got a tool for that, which is a bit more like a console tool, where you can see the log and the outputs of the techniques. Then we have the fighters, where we generate the code, we put it on PowerShell, and then we take it onto the Windows machine. See, that is my design, my Flash design. Well, you know, it could have been better, but I didn't do front end. I just deal with security. So anyway, every agent that connects with us will give the operating system picture. So if you have them in PowerShell, how can you execute them on Linux? Because you have a PowerShell every system that you can execute on any system. So the idea is that we migrate anyway our agent script to a different system with BAS, and that's it. So when we click on one of these, then we find this information, the agent identifier, its architecture, the PID where it is being executed, and last connection, which is really interesting to know whether that is still alive, and finally the IP that is sending the request. And here you have the results screen, which is very similar to the initial screen. We click on the agent, and then it's going to tell us whether the technique has worked or not. Is it okay or not? And this is the screen where we generate little fighters. So we just get the IP address, we click on generate, and what happens, I'm going to show you now because it's not on the slide. What else do we have? As I was saying, I would have had a console script, but you know, it had to look a bit more readable. So we have a script to manage all that log that doesn't look pretty on an application. So on the web application, we can see whether it has worked or not, whether controls have stop this or whether it's been executed. And then from the script, we can manage the results sample and the log. So everything really that the technique has given us output. And this is what it looks like on a console. Which one is better? This one, of course, yeah. Okay, so from here, we can list all our warriors. Then we can generate the plan on the base and database, and I'll show you how. And we see the results, and then we generate the code on PowerShell. Whilst I'm saying this, I'm going to lift a couple of machines so you see how they work. I'm going to let them running because they take a bit of time so that we don't waste time. Every time there's a demo, there's like some expectation, isn't there? Everyone is sort of waiting to see what happens. Now, it might not work. I'm just saying because that is also what comes with this. It's Murphy's Law, isn't it? Now, let's see whether this starts. There we go. Well, in the meantime, I'm going to show you how we generate plans. When we generate plans, the first thing that we get is an indication of all the techniques that we have loaded on the machine. It's on console mode, and you can see that it says function, technique, the name of the function, the technique ID, which is what we're going to use to then load it onto the database, and then the official URL where we can check the mitigation, procedure, examples, tactics that have been applied, how the technique has been carried out, and everything really we can see on this URL. So if we choose tactics, we can actually choose which functions we want to emulate. So ideally, we should get one or several threats and get an information of the techniques that we have to load in order to mitigate that threat. And then we have the log or result generation, where we can see by agent what every agent has sent back. So we see that one has failed, then another bypass has worked. There at the bottom you can see it, and it's reporting. So someone who really knows this can see a bit farther than the executive side that we've seen on the web application, which was just okay or not okay. Here we can see in detail the results of the emulation. Well, Windows 10 takes some time.
Vale, ya está.
Right, so now we're going on to the demo. Right, This is the adversary emulation. This is our initial page. We haven't executed anything yet, but we're going to go on the code generator. We're going to add our node's IP, and you can see this little code that it's sending back. This is a little script, little code that is going to download on that console function that has 70, maximum 100 lines, and this is going to manage the plan and then report on the results. So if we copy this and then paste it here, we execute it. And you can see that it's there and it's saying there's no plan. So if we go back here to home, we can see a new agent. Now if you connect with that agent, we see where it comes from. Last time that it's been online, the PID, the identifier, Windows 7, and the name of the machine. Now this has changed, as you can see, the time has changed. So if we go onto the debug, it's asking us for a plan, but there's no plan yet. So now we're going to do this quickly because we don't have that much time left, and we're going to generate the plan, and here everything's been implemented, but we're still adding techniques. We've got the tactics catalog here, which come from the matrix, and now we have to add the techniques. So we have to look for the function identifiers, and we will need a list, as we were doing with the faces. We have to make it look pretty. And then it's going to start asking which techniques we want to use, and then we can choose, for example, 2, 0, 1, 3, 4. And once we know that those techniques emulate a certain thread, then we stop, and then it will ask us, well, what agent would you like this plan to be applied to? So we add our agent's identifier, and now it's working. See, at some point it will ask, is there a plan? Yes, there is a plan. Well, then give me a plan. So give me plan, give me task. There's one of the techniques that on the results generation that it's interaction with the user, and we have this password. This is like a phishing, really, that we're doing onto the system. So at some point there will be no plan because all the techniques will have been executed, and now we can go and check the results. We can check them here. We see the name of the function that we will then have mapped with the technique of the matrix, and the results that it has given. This has not worked because the process had not been elevated, and this one would have needed an elevated process. We have the events, the credentials, and so on and so forth. So this is a quick view of what has happened, and then here we can see the detail. This is a bit more technical. Now this is the real output of the process that and what has been executed during the process. And this is a snapshot, text snapshot that usually comes up in red on PowerShell. Not very pretty, but you just get the error output so as to see that when you executed something, this happened, and so you return that. Now, a technician, based on this, can assess these outputs and know exactly what has happened during that emulation. Right. We only have 2.5 minutes left. And we're just going to the conclusions, our to-do list. This is a tool that I want to keep developing, that I want to still improve a lot. And I want to concatenate actions, which is, I think, key for the emulation to be as real as possible. I want for the agents to be able to execute threats, because doing it in this way, one after the other, might actually block the process, and so the agent might end up dying when it hasn't finished reporting everything they could have reported. I also would like to show the results of the threats in a more executive but at the same time visual way, and then obviously to map the whole matrix catalog so we can use this tool as something that can be used in a real environment. Now, this is a concept test of what you can do with this matrix. So just the conclusions that we draw, the emulation of adversaries helps us test our protections and our machines in an organization. We want to emulate the real threat through this application and do so in an controlled environment, or as much as we can anyway. So it's really important that the new knowledge that we get, in the same way that MITRE updates its matrix, and it does it very, very often, by the way, or quite often anyway. So what we want is for our machines to also be able to add all that knowledge that we are acquiring and to be able to share it with the rest. So if you have any questions, anything you'd like to ask, we've got 30 seconds. Thank you very much. Hi, I wanted to ask the external servers, the agents, are those the ones you have infected? Yeah, this is when the machine has been compromised. So ATT&CK is what can happen once the victim has been compromised. What can we actually get to do with a compromised machine? And do those computers not need anything other than PowerShell? Yeah, PowerShell if it's Windows, or for Mac and Linux, you can see that just with Caldera you can do it. Thank you. Thank you very much for the presentation. I couldn't see you, sorry. There we go. I just wanted to know if this tool is available on GitHub, or it will be. It will be. I still need to do some more work on it, and we would like to do it properly. So we're still going to develop it a little bit further, and we hope that by 2020, this will be obviously open source, and we hope that by 2020 people can start using it and getting to know it, because at the end of the day it's a matter of helping the teams who deal with these sort of actions, and also for people to get to know through this matrix, which is very important, all the knowledge that we have been gathering throughout all this year, which is really, really important and very interesting. There are some techniques which are complex, some others are not that complex, and in this way we are also encouraging people to learn through that matrix. Any other questions? Well, Pablo, if you could just answer your questions just outside, because we're running out of time. Thank you so much for being here.